So I've decided to upgrade my main system with a M.2 drive, this M.2 drive, because it already has a system disk that's an SSD, but the home partition, it's a Linux system, so home is a spinning disk, so an old hard drive, and it's quite slow. Well, it appears to be a bottleneck in the system anyway. So what I've decided to do is replace it with this, and then I'll use the existing old hard drives as a kind of RAID 0 backup and data space. The motherboard I have doesn't have M.2 spaces, so I've got a PCIe to M.2 adapter. So let's have a look. These arrived in the post. So I'm hoping that this will sort of make the machine, which is actually quite powerful, more responsive basically. I use it for work, so it's my main work machine. It's used mostly for, well, to be honest with you, it's mostly for kind of emails and things like that, but writing documents. But I also do use it for quite a lot of kind of, well, medium level computation, so not super heavy, but kind of, you know, things like a little bit of R and MATLAB, that kind of thing, some Java simulations, some large-scale data processing, big spreadsheets, other things like that. So it's useful to have as fast a system as possible, basically. So it looks like this is a little bit of self-assembly required. That's a heatsink, obviously. It's very strictly not necessary, but maybe useful. And that is the adapter plate itself. So I need to check which way around it goes. And here's the manual. Install the right adapter. So it's got a low profile adapter as well as a full size one, which is quite handy. Okay, so it actually suggests putting thermal paste below. No, it doesn't. That's a stupid thing to suggest. Yeah, so shove in your drive, screw it in, stick the pad on, whack the heatsink on top. Seems reasonably straightforward. So I've got a set of screwdrivers. I'm hoping this will speed up not only my kind of computational work, which I'm sure it will, but anyway, just things like opening Chrome and stuff like that, which, you know, Chrome these days is quite a heavyweight application. And if you've got, like me, maybe if you're working on a piece of research or something, you can have quite a lot of tabs open at once. And that can be a reasonable strain on the system. Not like massive, but you know. This is a 1 terabyte M.2 drive. Performance is pretty good. I mean, I didn't go for like the highest level performance ones available, but I don't think it will make a whole lot of difference for what I want it to do. And it'll be a big improvement over my existing setup. Let's have a quick look at what a screwdriver I need. Relatively small crosshatch. Probably do it. So I've got screws here for the device and for mounting it onto the backplane as well. Just try and work out which screws are which. Looks like the small flat one So I've got 3 of them. Three of those, they look like part of the 3 of those. So let's have a look. So I assume this will only fit in one way. Yes it will, and it's the end one obviously. Put that on there. So it looks like these go in the back. And oh sorry, that goes on the top. To make a hole in that. It's a plastic film that goes over the screw hole there, which you might have gathered. And then this on the back. Goes in there. And then presumably you can now fit that in there. And it should just screw down. It would be easier if I had a magnetic screwdriver, but never mind. Probably put it in a little bit actually. Might go past it with a bit of luck. Yes, it will. That doesn't make sense because that doesn't screw all the way in. Ah, I wonder. No, actually. Okay, so reading the manual is a good thing to do. This comes off. And then so it says remove the protected film from the card. Remove the gold spacer and a silver pan head screw from the screw set. Use the screw to fix the space to the length that you need for the M.2 SSD. So I was right. That goes there. That goes in the back. I was right the first time. Then it says take the grey heat conductive pad, remove the protective foil on both sides and apply it to the golden surface. Pink headed ears independently. So they're all the same. Grey. Which one is grey? They all look the same colour. Just going to put that back on there in a minute. Grey. What do you reckon? Hint. Thick pad, single-sided SSD. Thin pad, SD equipped on both sides. The pad is too long, you can always shorten it. Okay, so I'm going to go with one of these. And this is indeed single-sided, so we'll go for the one I originally picked. Perfect. Stick it on. Just turn this around. Roughly the right place, a little bit nearer, so we don't want it to interfere with that screw. And there's a plastic cover. size only moderately sticky. Okay. Carefully detonate approximately 30 degrees and then press down, secure it with the rear end with a second silver screw. Not a black screw. Second silver. There we go. Excellent. Then what? Take the blue thermal pad, remove the protective foil from both sides and apply it to the SSD. So there's two blues. A thick one and a thin one. Okay. So what I'm going to do is I'm going to test it. I'm just going to pull that off. There you go. And pull that off. No. Test it with this. See how it fits. So goes with the logo at the top, and so that to me feels like it's making pretty. Screw that down will require compressing the thermal pad a little bit, but not too much. So let's try with this one. I actually think that's better. So the thinner of the two blue ones in this case. Off. There we go. I was a bit reluctant to okay, so I'm just need to get this positioned correctly, so I'm going to line up with the top and then just let it drop. Seems to be good. I got 4 small screws, which makes sense. Just felt that pad squash onto it, so probably got reasonably good contact. Whether this heatsink is strictly necessary, I don't know, but there isn't particularly masses of airflow in my case. So it probably won't do any harm. Perfect. Okay. Feels pretty good. Yeah, and I can see that the thermal pad has made contact with the heatsink. Right. Next, fit the correct bracket, which in my case is this bracket. Okay, slightly beefier screws there. Seems like you get spare screws basically, like one of each. There's a spare kit and potentially spare heatsink. So this bracket was about £15, which isn't too expensive. What I'm going to do here is going to poke the screw through and then put this on. And the drive itself was about £100, I think, because I think the whole thing was about 120, which is pretty close to the price of a normal SSD. So a normal SSD, 1 terabyte, there's a bit less than 100, but not a huge amount. And then I would have probably needed something to mount it in, which would have added a little bit of extra cost. Also, because the work machine boots Windows and Linux, it's actually quite full of hard drives, so I would potentially have had to have bought an extra hard drive controller anyway. So, okay, there we go. So that's pretty neat, really. A logo on the top, and seems pretty solid. So I'm quite impressed with that. So hopefully, I mean, I'll show you how it gets installed, but hopefully that will significantly improve the performance of my system day-to-day use. It's all that home drive. I've got about 600 gigabytes of use on my home drive. So this will have a bit of headroom, but also there are things that I can potentially shuffle off my home drive onto the data drive, things that I don't use very much, or it doesn't matter if it's slower. Great, okay, well now we'll look at how we actually install it. So this is the system that I'm putting it in. Let's see if I can show you. There is, so the graphics card's in the bottom 16 times slot. That's mainly because this massive cooler slightly obstructs the top one, because it just slightly overlaps. It's a bit of a pain, but doesn't matter when you've only got one GPU, I suppose. Cable management's not the best in this case because you can't thread them behind. There's no gap at the top, so they tend to end up having to go up the front, which is a bit of a, it's not ideal, but I mean it's okay. So it'll go in that 8x PCIe 3 slot there, which you can see. Don't know whether you can actually see that the pins stop halfway down, which is an easy way of identifying the 8x slots versus the 16x slots on this board at least. So yeah, so see if I can balance this without it falling in. Got a bit more light there as well. Okay, it's probably about as good as it's going to be. So here's my card. I'll just pop it in there. So that clipped in, no trouble at all. Let's put the thumb screw back in. There we go. So this system is a little bit old now. I can't remember exactly how old it is. probably 4 years actually, so maybe longer actually. It's a Xeon E51660V2, I think, which is 3.7 gigahertz, 6-core hyper-threaded, so 12 cores altogether. When it was new, obviously it was pretty quick, and it's got 64 gig of DDR3 RAM, which you can see in those 2 banks there. So it's pretty decent for a workstation. This is an old 6600 Ti, I think, NVIDIA. Yeah, so it was pretty well spec'd when it was new. It's decent enough now as well. It still does all the things that I need it to do. It's not too noisy. All these fans are speed controlled by the motherboard, so that actually means it's not too bad. In terms of noise, it's not the quietest, but certainly not too disruptive. And the hard drives are down here. 2 hard drive cases. They're pretty full, so there's Windows, there's 2 terabyte Windows drive, a Windows SSD, there's a boot SSD for Linux, there is a dumping ground 1 terabyte hard drive, which it's got things like SQL databases on it and some other crap. And then there's a mirrored, I think it's 2 terabyte mirrored RAID home partition, which is what is being replaced. So that the M.2 drive will be the home partition basically, and the original mirrored drive will just be for storage and backup. Most of what I do day to day is actually backed up in my own cloud, which is actually own cloud. So I don't have to worry too much about the RAID mirroring anymore. So that's all right. So yeah, I'll just set up the system now. So I'm using Ubuntu Live CD. You can probably hear whirring away in the background a bit. Yeah, apologies for the audio. I'm on a webcam, but needs must. So this is the system that the drive's going to be in, and I booted a live CD in because I want to copy the home partition without obviously just essentially copy it without it being used. And this is one of the easier ways to do that, although it has actually turned out to be more of a faff than it should be. So we can see the drive detected here. That's the usable space. Obviously it has no partition on it, and then one or either of SDA or SDD is my home partition, and I will have to mount them to have a look to see which one is which. So that's basically the first job to do. So what I'm going to do is make some mount points. So I'll have the M.2 drive and old home, and then the first thing we'll do is mount SDA. Yep. Alright, that is my Windows drive, so that's no good. Well, we'll try SDD first. SDD1, Linux file system. SDD1. Old home. And then if I open a should be here. There it is. It's a bit strange. Maybe I can't see it. Did it mount? No. No, because it's the wrong command, you div. I don't know what the file system is. I can't remember. So if I refresh this now, it should show up. Actually, if I mount that, I need to mount the root drive anyway, so I will mount that to find out what that one is. That's on a smallish SSD. That's the Windows one. That'll be that one, and it will be this one. So SDC2. Okay, so that's the root drive. And if we just have a quick look at this tab, this tab. It's backup, home, mount, backup. Home is this one, 91. So if we just unmount, check that. Okay. So back one, old home. Now we can be sure we've got the right drive. So we need to Partition is install. Departed. that's going to scan all the drives. It's found one that's unallocated, that's the right one. Nothing on there, so we'll create a partition table, not MS-DOS, we will go with GPT rather. And then we will create a partition, new partition. We'll go XFS. We'll give it a label, why not? Information, that's good. Apply that. Okay. So now if we do it should be there. And there it is. Copy that. Okay. Now we need a new home. It did. And then it'll figure it out. Copy that. New home. That's a case of copying all the data. So that's going to take a little while. I obviously won't record all of it because that would be quite tedious and pointless. So I'll pick this up later on. Left this video off at the point where I was copying all my data from the old hard drive to the new M.2 drive, and that took, well, a reasonable amount of time. Got about 500, nearly 600 gigabytes of data. And I had a little bit of problem with the screen capture system working in the live USB drive, so I didn't finish off the video in that live thing, but I can show you now basically what I did. So I found the UUID of the new drive and placed that into my fstab file in Linux and pointed that at home. So all the data had been mirrored across, and then at the next boot of the system, essentially this would be mapped to home, and as predicted, all my kind of systems, software, etc., they don't know the difference. It's mapped into the right place, so it just loads automatically, and you've essentially cloned a drive, basically. At the time, these were the old drives, and I've since reformatted one, so I'm sort of experimenting a bit with BTRFS RAID, but at the time I just loaded both the old drives into different mount points, and if something does go wrong, you've still got the old disks present, so you can always go back to how you were if some part of this setup hasn't worked. In my case it worked perfectly, and I've since reformatted one of the original drives, and we'll probably put the other one, which still has the old home space on it actually, but I will, don't know why there's a 3 there, it's probably a typo. I will set that up later to be a part of this mirrored BTRFS system. So was it worth it? Was it worth putting an M.2 drive in this system? It really was. The improvement is staggering actually. Just the day-to-day use of the system is much better, it's much more responsive, it loads more quickly. Setup of the user space when you log in is almost instantaneous. Browsers load instantaneously pretty much. So it was definitely worth it in my case. It's a relatively cheap upgrade to vastly improve a system. So I would highly recommend it. And it's pretty simple. I mean, if you're reasonably proficient in Linux, you can easily mirror a drive in this way. Windows is a little bit more tricky, but it's not impossible. Maybe that could be a video for the future. Okay, so thanks for that. Definitely worth doing. If you've got a reasonably good spec computer that you're finding a bit slow, a £100 upgrade could really make a massive difference.